Ladies and gentlemen, welcome to this conference and thanks for your attention to my presentation. Before beginning to my presentation, I would like to thank the conference committee for this nice organization and introduce myself to you. My name is Buket Arık and I am an academician in Pamukkale University, Faculty of Engineering, Textile Engineering Department in Denizli, Turkey. Today I will present you a part of the master thesis of my student Deniz Yıldız. The subject is the comparison of the effects of water and oil repellent processes on model fiber-based fabrics. The presentation is composed of 5 parts as the abstract, introduction, materials and methods, results and discussion, and conclusion. With this content, I will explain the aims of the study, materials, methods, initial results, and the conclusion. In this study, it was aimed to enhance the water and oil repellency performance of the knitted fabrics made from model fibers that are originally in hydrophilic structure and determine the optimum process conditions to obtain washing durable performance and acceptable physical properties. For this aim, fluoroalkylglyoxane as a water and oil repellent agent, beta-cyclodextrin as an auxiliary agent, butane tetracarboxylic acid as a cross-linking agent, and sodium hypophosphite as a catalyst were applied in different processes. The water and oil repellency performance properties of the model fiber-based fabrics were compared before washing and after washing cycles of 1, 5, and 10. In order to determine the effects of the treatments on physical properties of the samples, bursting strength, thickness, whiteness, and yellowness values were measured. The excellent washing durable water and oil repellent performance properties were achieved by the application of 10% fluoroalkylglyoxane, 10% beta-CD, 10% butane tetracarboxylic acid, and 5% sodium hypophosphite. The effects of this treatment on physical properties of model fiber-based fabrics were also found to be acceptable. And what is model fiber? Model fiber is a kind of regenerated cellulosic fiber. As you see in the figure, regenerated cellulosic fibers can be divided into 3 classes: viscose, model, and tensile. When compared to the viscose fibers that are the first generation of regenerated cellulosic fibers, model fibers are known to have higher wet strength, higher comfort, and higher performance properties. Model fibers possess also soft, smooth, and shiny surface properties. In addition, their hydrophilic characters due to the hydroxylic groups in the anhydroglucose units enable ideal moisture management. Cyclodextrins are cyclic oligosaccharides degraded from starch and composed of 6, 7, or 8 alpha-D-glucose units linked by alpha 1,4 glycosidic bonds. Beta-cyclodextrin, which has 7 alpha-D-glucose units, is the most preferred one for the textile applications due to be biocompatible, biodegradable, quite cheap, and available in large quantities. Cyclodextrins can form inclusion complexes with essential oils, antibacterial agents, and oncogenic compounds. Moreover, they improve the chemical stability of these agents by preventing oxidation and by controlling the release rate. For textile industry, the main used applications of cyclodextrin are dyeing, printing, finishing, and wastewater treatment processes. But using cyclodextrins with water and oil repellent agents in order to attain washing durable performance has not been studied yet. In addition, there are still limited studies about the finishing treatments of model fiber-based fabrics. So in this study, water and oil repellency performance against repetitive washing cycles and some physical properties of model fiber-based fabrics were compared by applying different process alternatives. In the study, model fabric, fluoroalkylglyoxane, beta-cyclodextrin, butane tetracarboxylic acid, and sodium hypophosphite were used. Application processes you see in the table. The chemical solutions were prepared, mixed in the magnetic exterior and applied to the model fabric by padding machine. For treatment 1, fluoroalkyloxan was applied in one step, while in the other treatments it was applied in the second step. After padding, the model fabrics were dried and cured. For two-step processes, in the second step was applied after curing, so in the first step beta CD was fixed on the fabrics, and in the second step inclusion complexes with fluoroalkyloxan were formed. And then washing processes, water repellency test and oil repellency tests were applied. Physical tests, the bursting strength values of the samples, the thickness values of the samples, and the whiteness index and the yellowness index of the samples were measured by the machines you see in the figure. They measured 4 times and average values were calculated. And results and discussion. Water repellency test results. Firstly, according to the spray test results, the score of untreated bonded sample was found as 0. That means this fabric was hydrophilic and completely wetted. On the other hand, treated model fabrics showed quite excellent scores and their surfaces turned to hydrophobic structures. After first and fifth washing cycle, there was no significant change, but after 10th washing, the hydrophobic performances decreased. The model fabric treated without beta CD, butane-tetracarboxylic acid, and sodium hypophosphite showed lower performance compared to others. And add-on percent values, that are the weight gains of the samples after wetting, showed that untreated sample was quite hydrophilic, and the treatments enabled very well performance in terms of water repellency, since all the values under 15% before washing. After washing cycles, add-on values increased, but in the samples treated with beta CD, this increase was more controlled than the sample treated with only fluoroalkyloxan treatment 1. And oil repellency test results. According to the oil repellency test results, the samples treated with beta CD showed better performance than the sample treated with only fluoroalkyloxan. The effects of butane-tetracarboxylic acid and sodium hypophosphate were not significant until the 10th washing. After 10th washing, it can be said that the addition of butane-tetracarboxylic acid and sodium hypophosphate with beta CD enabled improved oil repellency performance for 1 score point. On the other hand, the fact that the concentrations of butane-tetracarboxylic and sodium hypophosphate were not the same did not cause any change between the treatment 3 and 4. According to the bursting strength results, the treatments without butane-tetracarboxylic acid and sodium hypophosphate addition did not cause significant decrease, while the cross-linking reaction clearly decreased the bursting strength. On the other hand, since the increase of the concentrations of butane-tetracarboxylic acid and sodium hypophosphate twice did not alter the bursting strength values much, it can be said that the concentrations of 10% butane-tetracarboxylic acid and 5% sodium hypophosphate were also acceptable. The thickness results showed that the thickness values increased by the increase in concentrations of the applied chemicals. Whiteness and yellowness index showed that the treatments caused a decrease in whiteness and an increase in yellowness. On the other hand, since the values of all treatments were quite close, the effect of the addition of beta CD, butane-tetracarboxylic acid, and sodium hypophosphate was found to be negligible. And as a conclusion, water and oil repellent treatments with fluoroalkyloxan, beta CD, butane-tetracarboxylic acid, and sodium hypophosphate were applied to model fiber-based fabrics in different combinations and concentrations in this study. The water and oil repellency performance of the samples before washing and after first, fifth, and 10th washing cycles were determined, compared, and discussed, Moreover, the mechanical and physical properties like bursting strength, thickness, whiteness, and yellowness were also measured. According to the results, treatment for 10% fluoroalkylglyoxan, 10% beta-cyclodextrin, 10% tetracarboxylic acid, and 5% sodium phosphate was found to be favorable method both for excellent washing, durable water and oil repellent performance and physical properties. And thanks for your attention.